Alrighty, today we're going to be looking at volume of pyramids. Pyramids, commonly known as pointy shapes, for they all have a pointy bit at the top, have a very easy and quite straightforward calculation to actually make. Why? Because their volume is almost identical to that of their prison brothers. Now, note for each of these that they still do have a base, just like the other one, and we're going to use that base. Now, the interesting thing about pyramids is that the volume is just a third of what it would have been if it was a pyramid. It's an unusual one, but the more you look at it, you realize that by cutting away so much of the shape, you are left with about a third of it. Just make sure, though, that the height we're interested in is the perpendicular height, not the angled height. That is not what we're after. We call that distance usually the slant, and it is used for surface area stuff, but is not used for volume. It needs to be the right angle height. Alrighty, so let's look at some example calculation. Alrighty, so this first shape here is a cone, or technically and totally uselessly, a circular-based pyramid. So it's a pyramid, so volume is equal to a third AH, and in this case, the area we're looking for is of a circle. Now, we know pi, but we don't actually know r, because that's the diameter, so r is going to be 5 over 2, which is 2.5. So we're going to get pi times 2.5 squared, which is equal to, which gives us 19.634954, which I'm going to round there. Now, you might look at that and say, that's a lot of decimal places. Why are you using so many decimal places? It's because I don't want to round too early. Most questions are probably going to ask for 1 to 2 decimal places of precision. If you round here to 1 to 2 decimal places of precision, you're going to lose that information later. So I am going to keep this. The easiest way to do this is to use your answer key on your calculator. If you're not good with that, though, you will just have to carefully type in all of these digits. Since we're talking centimeters, area is square centimeters. So now we're ready to do the volume part. So it's going to be a third times 19.634595 times the height of 8 centimeters. And that's going to give us the final answer. And that gives us the answer of 52.3598, which to 2 decimal places will just be 4 cubic centimeters, or 52.4 milliliters, just as a reminder. Alright, let's look at another one. Okay, let's look at quite a different shape. Now this one is a triangular-based pyramid. We've got the pointy bit down here, and then we've got the base, which is this little triangle up here. And just as a note, whenever you're doing this, I think it's always, whenever you're dealing with triangles or trapeziums or parallelograms where you've got h variables here, it's always good to just extra be careful. This is base and height of the triangle, whereas this is the height of the pyramid. So volume is equal to a third BH AH, where A is equal to a half BH. So this is just our triangle distances. So the base is 1.8 and the height is 0.2, which is equal to 1.8, I believe. Sorry, 0.18 square meters. And so for the volume, it's going to be a third times 0.18 times the height, which was 2 meters for the prism, which is equal to 0.12 cubic meters, which, if we wanted to convert into, say, milliliters, well, we could immediately convert it to kiloliters. No conversion actually required, and then we could multiply by 1,000 to get it into liters, which would be 120 liters. Okay, so just to kind of give ourselves a little bit of playing with the capacity stuff we learned last time. See you in the next one. Goodbye.